Welcome class to Learning Outcome 19 PowerPoint video for Math 2015. In this learning outcome, we're going to extend our base 10 division to correctly model polynomial long division using manipulatives, pictorial representations, verbal descriptions, and variable expressions. So how do we define division? Well, we're using the efficiently counting idea. We're going to take a total and efficiently divide it up into groups. Well, we want to know from a total what the number of groups are and the number in each group. We also want to know the number in each group when we know the total and the number of groups. So division is just essentially putting objects into the same size group. It's also in the inverse of multiplication. Okay, so to review, we have this multiplication problem, the inverse multiplication. Okay, so if we have A times B equals C, A is the number of groups, B is the number in each group, and C is the total. Okay, that's the multiplication equation. Now, when you are efficiently counting the number of groups when you know the total and the number in each group. So the total was C, and when I don't know the number of groups, that's I don't know A. So for division, we take our total C and we divide it by something else we know, which is we know the total and the number in each group. So the number in each group is B. Okay, but we don't know what A is. Okay, we don't know the number of groups. This is the measurement division. Okay. When we have the total, and we know the number of groups, which is A, we are going to get the number in each group, which we don't know. This one's called partitive division when we know the number of groups. We're just kind of dealing out everything to each group. Okay, so that's a reminder of what division is. Polynomial division, okay, again we're going to go back to partitive interpretations. Given the total and the number of groups, how many will be in each group? Measurement was given the total and the size of each group, how many groups will there be? The inverse of multiplication, okay, so given A and B, and dividing A by B means finding the number multiplied by B to get to A. A divided by B, B times what is A? Okay, so we just kind of went over that one. Division interpretation could also be finding a missing factor in a dimension. So in this slide, we have a rectangle for multiplication version and then division version. The multiplication version gives us the 2 dimensions. This is 9 units, and this is 15 units here. Okay, so when you multiply 9 times 15, you get the area, okay, in square units. With division, you're starting with the total area, you know one of the dimensions, but you have to do whatever it takes to figure out what the other one is. Okay. 9 units divided by, oops, let's start that one over. We have 135 units squared divided by 9 units will give me 15 units. Okay. So this is what we didn't know before. So what we're going to do in this one is we're going to draw a base 10 block illustration of the entire process of dividing 1025 by 8. We're going to work through the algorithm and then connect the steps to our drawing. Okay, so we're doing base 10 blocks. Okay. With base 10 blocks, we're going to have to use a key. So we know we're going to say, and our biggest place is 1,000, so we'll just take the regular key. Where the big block is 1,000, the flat is equal to 100, the rod is equal to 10, and the little dot, which is the unit cube, is equal to 1. Okay. So when I diagram 1025, I have the 1,000 block, two rods, and then 5 ones, which I'll diagram later. Okay, but right now we're going to need to draw in our bins. Okay, so I want 8 bins. Okay, there's 8 bins there. 1, 2, 3, 4, 5, 6, 7, 8. Okay. But I can't take my 1,000 block and divide it into 8 bins. I have to break it up into pieces. Now the next unit down is going to be flats. Okay, so I have 10 flats. I'm going to use 8 of them in my bins. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Alright, so now I have those divided up. I don't have any hundreds in my 1025, so I'm just going to take these two hundreds and then divide them up into 10 flats, or 10 rods each. There's 10 there. There's 10 there. And I'm going to add that with the 2 rods from the 1025. Okay. So I have 12 rods. Well, I only have 1 rod for each group because there's 8 groups. Oh, I'm sorry. There's 22 rods. Okay. And I'm going to do two rods for each group. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. That used up 16 of rods. So how many do I have left? So 1, I have 4 rods left, plus another 2 rods from the 1025. But now each of those are going to be broken up into units. Okay. So I need to break them up into 60 units. Okay, I don't have room for 60 units. Let's see if I can try and fit that in. These are going to be little dots. 60 units. Okay, so we have 60 units here, and we're going to divide those up into 8 groups. So 60 divided by 8, well, and let's think about missing factors. 6 or 8 times, 6 times, oh yeah, so I'm going to divide into 8 groups. 6 times 8 is 8 times 6 is 48, 8 times 7 is 56. So 56 is going to be the amount of little dots I'm going to use with 7 in each group. And that used all of them, but this 4 here. So we have 8 times 7 is 56 dots. Okay, so we have a remainder of 4. Let's go ahead and compare that with our algorithm. So we're doing 1025 divided by 8. So 8 into 10, or 10 hundreds, is equal to 1, and you get 2 left over. Oh, I also got to put down the 5 dots. From the 1025, that makes more sense now. So there's 4 and 5 dots, and I'm going to put one of those into each one, so there's one remainder. The remainder is 1, so I'll put one more dot in there. So each group has 8 dots in it, 8 units. Okay, so 10 minus 8 is into 22, goes 2, because you have 16 there. 12 minus 6 is 6. Okay, so there's 6 left, and then bring down the 5. 8 times 8 is 64. And that's a 1. So 128, remainder 1. And we have the steps. So there's 8 tens used. So this step corresponds with these right here that are used. Okay. There's 22 left over. These ones are these 22 right here. There's 65 dots left over. That's these 65 here. And one remainder is this one right here that's not being used. Okay. So 128 remainder 1. Oops. Which we have the quantity x squared plus 6x plus 8 divided by x plus 2. The quantity x plus 2. The quantity on top is all-encompassing. That's why I say that's just one thing, because the division bar goes through the whole thing, which implies those are parentheses. It implies that these are parentheses. And what does this mean? I have x squared. I'm going to draw little algebra tiles. 6 x's, 2, 3, 4, 5, 6, and 8 units. Okay, they're all open because they're not negative. And what I need to do is dividing by x plus 2. This is x plus 2 right here. I need to see how many of those I can take off. Okay. So here's a group of x plus 2. I can take off this one. There's one group. Okay. So how many of those can I take off, and I'm going to count them. All right. So let's go ahead and do this with missing dimensions and area models. This is going to be the video for the first problem, the quantity x squared plus 4x plus 3 divided by the quantity x plus 1. Okay. Alright class, we're going to go ahead and divide x squared plus 4x plus 3, the quantity x squared plus 4x plus 3, divided by the quantity x plus 1 using algebra tiles. First we're going to start out by modeling our total, or the dividend, by saying x squared, so we'll take one of these, plus 4x, it's going to take 4 positives x bars, and then I'm going to do plus 3, which is positive 3 units, 3 little unit ones right here. Now this is the total that I'm going to have to arrange in a rectangle. And my guidance for this is the divisor, which is x plus 1. So I have a positive x up here. Then you'll put another 1 on the side. Positive 1, which is a yellow one. Now, as we go down to our columns, okay, because I'm going to arrange the factor that we know in a missing factor multiplication problem, the x plus 1, I'm going to put that on the top, and arrange the rest of these in a rectangle so that whatever's on the side here, I can determine what the quotient will be, or the other missing factor. When I have plus 1 right here, the x, I need to put something here to match with the x squared, which matches with this x here, because that will go in that corner. Okay. Now what is the rest that I have? The rest I have is 3 units and then 3 x's. So we can arrange them in a way so that we put 3 x's here, because they have to go with the x column, the x squared piece right there. And here we have a rectangle. Now what I'm going to do is I'm going to see, okay, on this vertical dimension I have an x and then going to be 3 units there. So my answer is going to be x plus 3 along this vertical dimension. Okay, so the quantity x squared plus 4x plus 3 divided by the quantity x plus 1 is equal to x plus 3. I'm going to do the quantity x squared plus 5x plus 6 divided by the quantity x plus 3. In this problem, I'm going to divide the quantity x squared plus 5x plus 6 by the quantity x plus 3. So I'm going to, again, model this first polynomial with x squared, 5x's, so plus 5x's means positive 5x bars. Okay. And 6 positive squares, little square units. Okay, so I pulled them out in my working area, and I'm going to arrange them in a way that I can have one factor up here be x plus 3. So x plus 3 is going to be this x here, and 3 more units this way. So these guys are part of my total there. Right. So I've arranged the factor that I know in the top horizontal part of an area model, and then we're going to build down in columns. Now the intersection from x and this missing factor is going to be x squared, so the x squared will go right here. These are 1 units, and this is x squared, so we need to match them up with an x bar, all 3 of them. Okay, and so that's as much as I can do on the horizontal factor because there's no more units on that way. What I need to do is I need to arrange these two x bars and these 6 positive units in a way that they will make a rectangle, so that the dimensions of the horizontal and vertical parts are the same. So notice that I've put 2 x's here, and then I have fit in all of the 3 by 2 little grid there, array of units. So we have x plus 3 on this dimension, the horizontal, and then the vertical will be an x and then 2 more units. So it's going to be x plus 2, an x here, and then 2 more units this way. The division of
x squared minus 5x plus 6 divided by x minus 2.
In this video, I'm going to show the division of the quantity x squared minus 5x plus 6 by x minus 2. Now we're going to have a problem type where we have some negative parts to it. So I'm going to model this polynomial first with my x squared. My minus 5x is going to be 5 negatives x's. Okay. So 5 negative x's, there's 1, 2, 3, 4, 5. They're marked in red. 5 negatives. And then I'm going to model 6. I need 6 of these positive ones. 1, 2, 4, 5, 6. Okay. And I need to model this with x minus 2 at the top. So positive x bar, and then negative 2. So I have 2 negative units here to go with my positive x bar for x minus 2. Again, I'm going to arrange everything that is in the total or the dividend in a rectangle. My clues are the x, positive x bar, and the 2 negative units. When I fill in down this way, I need to match the 2 negative x units with these negative x's here, because all I have are negative x bars. The other ones I'm going to put in this column here because this positive x has to be that long. Okay, it has to be x long. Okay, so I have 2 of the x bars here, 3 of the negative x bars there. And then I have my units here that have to be arranged to match the units this way and the units this way. Okay, so I have a 3 by 2 array for positive units, and they'll match up because we have a rectangle now. Okay, so what is this dimension here? This vertical dimension, which is my answer, my quotient. It has to be an x here, and it's going to be positive x because this positive x and that positive x need to make x squared. Okay, so this is positive x that way. And these 3 are negative units, because it's going to be a negative unit and a positive x to make the negative x bars here. And that will check out because the negative units, these 3 here, will match with these 2 negative units to make positive units, because a negative times a negative is a positive. Okay, so x minus 3 is going to be our answer.
We're going to do the quantity 2x squared plus 5x plus 2 divided by the quantity 2x plus 1.
In this video, we're going to show the division of the quantity 2x squared plus 5x plus 2 divided by 2x plus 1. So we're going to start by modeling this polynomial with some algebra tiles. So I have 2x squared this time, and I'm going to add on 5 more x's. So I have 5 of these x bars here, pieces. Okay, so I'm modeling again the dividend or the total. Then I'm going to make it a rectangle. Okay, so there's 5 of those set next to my x squareds. I also need a positive 2. Okay. Now along the top horizontal dimension, I'm going to model 2x plus 1. it's going to take 2 more x's here, model them along here, along just this line here. 2 x's. And then I need to do a plus 1, which is 1 positive. Okay? Alright, now I need to fit these into a rectangle arrangement so that it becomes the area model. Now this plus 1 right here will go compare with the x squareds, and we will only need to use 1 x bar here to fill in the rest of this row and to fill in the last column. The rest of my pieces here must fit down under my x squareds, and this is my x, and so I'm going to have to match them up. So the x bar length this way needs to match this way. So I have 4 of them. Okay, so to match the 2 groups here, I've put 2 and 2, and then I'm going to put the 2 units here to fill in the rectangle. Okay? So my pieces are arranged in a rectangle. I have 2x plus 1 here, be x plus 2 here. Okay, this distance is x, that's going to be 2 units to get the unit times x to be these x's. Okay, so I have x plus 2 as my answer to that one.
We're going to do the quantity x squared minus x minus 6 divided by the quantity x plus 2.
In this one I'm going to model x squared, the quantity x squared minus x minus 6 divided by the quantity x plus 2. And so here's my x squared. Algebra tile. I need to do a negative x here, and then a negative 6. So I'm going to take 6 of these negative pieces. Okay, that's going to be my total, or my dividend. And I'm going to put as the horizontal factor x plus 2. So I'm going to take 1 x bar here, and then 2 positives, put it next to it. Okay, and I need to fill in down this way. Since there are an x squared here, and then there's a positive 1 here, I can potentially put this x bar here, negative x bar, because this positive 1 plus times something here will give me negative x bar. So this one will have to be a negative x bar too. So that will work. But I need to fill in the same kind of thing here, because that's a negative x bar and a positive 1 again. But I don't have those pieces. And so when we had to put in pieces with the chips, we put in 0 pairs. So I need a negative here, negative x. So I can't just put in a negative x, I need to introduce a 0 pair, which is a negative x and a positive x. Okay, these two need to be inserted into here. Okay, this is one possible arrangement, maybe. We'll see how it goes, because I have to accommodate these units here. Okay, so notice that I have these ones can only be 2 units here, because this is going to be x plus 2. So these ones will have to go down here. Okay. Now so I have a positive x bar here. I need to introduce another 0 pair because I need another positive bar here. But these aren't matching up here very nicely. They do have the right amount of pieces because it makes a rectangle. But they have to be the same kind of pieces because this x bar needs to multiply by another x bar here, positive x bar, and then a few other things, but need to be the same. There has to be 2 positives here. So let's go ahead and switch these 2 negatives for these 2 positives, so that we can have the same type of unit in each section. Okay, so now we have the same type of unit in each section so that they can be the same type of number. because I couldn't have mixed the numbers here because it has to be all positives or all negatives. Okay, to be x plus something or x minus something. With this arrangement, we have positive x, positive 1 makes positive x. Positive x plus positive times positive 1 is positive x. This one will have to be a positive x times a negative unit to make it negative x. Same thing for these two. Positive x times negative unit to make negative x. Positive x times negative unit to make negative x. And when we come down here to these units, they check out too because that's a positive x times a negative unit. Positive unit times negative unit to get negative units. All through here. Okay. So this dimension here is positive x minus 1 unit, minus 2 units, minus 3 units, which is equal to x minus 3.
Now we're going to shift by this division of polynomials to using drawings of algebra tiles. Okay. So here we have lots of algebra tiles that we need to model this by. So we need to show how to draw it. This is going to be kind of like a homework problem where you show a drawing of the division using the area model. First you diagram out your x squared minus 7x. So I have x squared. Minus 7x is my fill-ins. So I'm going to do 7 of them. Kind of fill them in. Okay. Then I'm going to do 12s. And these are like the little squares. They're open because it's positive 12. Now I need to divide by x minus 4, which means that I need to do an arrangement here. This is what I have to arrange in a rectangle. Notice that the top one is x, subtract 4. Okay, 4 squares, let's say. They're all filled in. And I need to arrange these pieces here in columns. Now I know that this one's going to be x squared. Since I have one x squared, it has to have a dimension of x. And that the other dimension is going to be x as well. Now this is positive x squared and positive x here. These are pluses, which means that this one has to be a plus as well. And so that was taken care of. Excuse me. Now I'm going to go across this dimension here, the row, and then down the column. Now these ones right here have to be x length, because that's x length, but this is going to be negative, because these are negative right here. I'm going to do 4 negative x's to maintain the rectangle shape. Okay, so I've done those 4. Okay, now I have 3 negative x's and a set of 12 positives. All right, so when you have 3 negative x's, they're going to have to go this way to maintain the rectangle. That's negative, it's negative, and that's negative. Okay, so this right here is the x minus 4. This one here is x. But what do we need to do to put all of these positives in there? Okay. Well, those are all done there. I've done all of these. Okay, so here's my rectangle, but I need to figure out what goes in the rest of this vertical column. I need this to be negatives. This is negatives on the horizontal. And they make positives here, so that means that these have to be negative x squared, little units, not x's, anything. Okay, so that means that we have x minus 3 here. Okay. X minus 4. Alright, therefore we know that x squared minus 7x plus 12 over x minus 4 is equal to x minus 3. Okay. One more for missing dimension. We need x squared plus 4x minus 12 divided by x plus 6. let's model our x squared. It's positive x squared. Positive 4x's. And subtract 12, which means minus 12's. Okay, all of these need to be arranged into a rectangle according to the one clue that I have. X plus 6, positive x, positive 6 squares. Okay, this right here, x plus 6. My only clues is this x squared, this positive 4x, and those negative 12 units. Now, just like tradition, this is going to be an x squared because I want to do that. Okay, it has to be. It's a positive x squared. That means that both the x on the horizontal dimension and the x on the vertical dimension are positive. Which means that if this is a positive x and this one is a positive 1, then these all have to be positives. Okay, but I don't have that many. Notice that I've used my x in only 4 of these. How am I going to get positive ones there? Well, I need to introduce a zero pair. Okay. So I start out with 4 positives, but I have 6 units, and so 2 of them are going to be introduced with 0 pairs. So there's our positive 0 pair, and negative 0 pair. Here, negative 0 pair here, because I'm putting these here because they are all full up here with this dimension. Now these are going to be 2 negatives here. And I need 12 units. So the negative 12 units are going to go this way because I need to arrange 12. It just so happens I have 6 units this way and 2 units this way. 6 units horizontally, 2 units vertically, and those 12 units are going to be distributed like in this way so they'll match up. So you have negatives on the right edge with that vertical dimension. Okay. 2 negatives there, and then all the other negative units to get to negative 12. So this dimension right here is my answer, and it's x minus 2. Okay, therefore, x squared plus 4x minus 12 divided by x plus 6 is equal to x minus 2. Of our lesson, we're going to study how to do this polynomial division without using algebra tiles. We're going to look at x squared plus 5x plus 7. And we're going to divide that by x plus 3. So we've set out our x squared plus 5x plus 7. And we're going to write the division with the same form as the standard algorithm using whole numbers. Next, we arrange x minus 3 of them. X plus 3 of them. X squared plus 3x, that is. Okay, so here's my x squared. Here's my x, x, and x. So I took them from here and put them around because this is also x minus 3 here. Okay. Plus 3, that is. And then I put the rest in an arrangement right here. That's going to be my x plus 6 plus 2. Okay. And I have the steps here to follow along with the picture. Well, let's draw the process here with symbols. X squared plus 4x plus 4 divided by x plus 1. Okay, so we have our x plus 1 here on the outside. X squared plus 4x plus 4. Now, when we do this division, we think about how many x's fit into x squared. Or what do I multiply using the missing product? We have x times
something is equal to x squared. So you think about what you need to multiply by to get to x squared. Okay, that's the same as x squared divided by x. Okay, so we actually know that that's x that goes in there, and we multiply x times x squared, x to get x squared, and x times 1 to get x. You subtract all of that off. So x squared minus x squared is just 0. 4x minus x is 3x. I'm going to consider the 4 now with everything by bringing it down. And we have x plus 1 into 3x plus 4. Well, that goes in 3 times, positive 3 times. We have 3x plus 3. When I subtract it, this is subtracting, I do my 3x minus my 3x, 0. 4 minus 3 is 1. Okay, so it's remainder 1, or x plus 3 and 1 over x plus 1. Because you take the remainder, put it with the divisor, put it over here as the fraction. Alright, let's try and work through this process with symbols too. So you have x plus 3 going into x squared plus 5x plus 6. Now x plus 3 is, how many x's do I get to x squared? Well, x of them. So we do x squared. And I'm going to multiply these. X times x gives me x squared, and then x times 3 gives me 3x. So from the x and the 3. When I subtract all of that off, I have x squared minus x squared, 0. 5x minus 3x is 2x. Okay, add 6. And I'm going to add on whatever x is to get to 2x. So it's a multiplication of 2. So 2x, 2 times x here is 2x. 2 times 3 is 6. And it goes in evenly, so that's 0. Okay. Let's do a couple more. We're going to take the quantity x squared minus 7x plus 12 and divide it by x minus 4. So we have our x minus 4 going into x squared minus 7x plus 12. Alright, so taking the first term by first term, x into x squared. So x times what gives you x squared? Well, it's x. So x times x is x squared. And I need to multiply x by minus 4, so it's minus 4x. Subtract that off. Now I have x squared minus x squared is just 0. Negative 7x minus a minus 4x is negative 7x plus 4x, which gives a minus 3x. So we're going to add 12 down here, bring that down. And we have minus 3x plus 12. So the difference between x and minus 3x is multiplication of negative 3. So put minus 3 there. It'll be minus 3x, and then I have minus 3 times minus 4 gives me positive 12. If I subtract this off, I'll get 0. Okay, so x squared minus 7x plus 12 divided by x minus 4 is x minus 3. Here's another one. 2x squared plus 5x plus 2 divided by 2x plus 1. Okay, so we have 2x plus 1 going into 2x squared plus 5x plus 2. Okay, so what's the difference between 2x and x squared? Well, it's the difference of x. Because x times 2x is 2x squared, and x times 1 is just x, so plus x. I need to subtract that from my polynomial because I've already considered those in my grouping. So 2x squared minus 2x squared is 0. 5x minus x is going to be 4x. Bring down my plus 2. And I have 2x and 4x has a difference of only positive 2. So 2 times 2x is 4x. 2 times 1 is 2. is 0. So, therefore, 2x squared plus 5x plus 2 divided by 2x plus 1 is equal to x plus 2. Okay, time for homework. Please let me know if you have any questions. I hope you enjoyed the video and knowing the great power of both a concrete and a abstract method to divide polynomials.